Hello and welcome to Module 2 of Geography. In this module, we shall be discussing the Earth's structure and crust. That is foundation of physical geography. The module content that we should be looking at here include the Earth as a planet, that is the shape, size and structure of the Earth, types of rock and rock cycle, minerals, that is definition and classification of mineral, soils, formation and types, natural resources from rock and soil before we draw our conclusion. The Earth is not a perfect sphere. It is not a static stage, but a dynamic, evolving system. The structure, it is best described as geoid, meaning it is slightly flattered at the pole and bulging at the equator. That is to say that the Earth is a dynamic and evolving system. Its structure is from the core to crust, drives everything from mountain building to resources distribution. Understanding the Earth is crucial for natural hazard mitigation, that is earthquake and volcanoes, resources management, that is management of resources from water, minerals and soil, and environmental sustainability. The thesis is the Earth's crust and its material form the essential foundation for all lives and human civilization. Now let us look at the shape of the Earth. The Earth is not perfect sphere. It is best described as geoid, meaning that it is slightly flattered at the pole, bulging at the equator, flattened at the poles due to rotation. Now let us look at the key measurement. The equatorial dimension of diameter of the Earth is about 12,756 kilometers. Then the polar diameter is about 12,714 kilometers. Then the equatorial conference of the Earth is 40,075 kilometers. Then the total surface area of the Earth is 510 million kilometers square. That is 70% of water and 30% of land. So this is the structure and the shape of the Earth. The size and shape influences climatic pattern, gravity, and geodynamics processes. Now let us look at the internal structure of the Earth. Let us look at the internal structure of the Earth. That's the composition. The Earth is composed of three compositional layers reviewed by seismic wave. The first layer is the crust, which is the thin and solid outer shell. Now let us look at the continental. The continental of the crust is thicker, which is about 20 to 70 kilometers and less dense. Then it is oceanic, which is thinner, that is about 5 to 10 kilometers and denser, and it is also denser, that is basalt. Now the second layer is the mantle, which is 84% of the Earth's volume. It is solid but plastic, driving plate tectonics. The mantle is subdivided into upper mantle, which is the lithosphere, and the asthenosphere, and also the lower mantle. Now the third layer is known as the core, which is metallic in nature, that is iron and nickel. It is also subdivided into two layers, that is the outer core, which is mostly of liquids generated as magnetic field, and the inner core, which is solid due to immense pressure. The key boundary, that is MOHO, that is Mohorovic discontinuity between the crust and the mantle. So the MOHO is the boundary between the crust and the mantle. So this is the structure of the Earth. Now let us look at types of rock. Let us look at types of rock. There are three main classes of rock by origin. Number one is igneous rock, which is formed from cold magma and lavas. It is subdivided into intrusive and plutonic, that is cold slowly inside, and then the extrusive and volcanic, which is cold quickly on surface. We have sedimentary rock, which is formed from the compressed and cemented sediment. It is clastic in nature, that is sandstone, chemical, and organic coal. Then number two class of sedimentary rock is it contains fossil, that is earth surface history archive. Then number three class of rock is metamorphic rock, which is changed by heat and pressure without mantling. So this type of rock is formed by change of heat and pressure without mantling. The example is sheet, that is non-pholite, and marble. So these are types of rock that we have in geography. Now let us look at the rock cycle, that is the Earth recycling system. The rock cycle is a continuous process of rock transformation over geological time. In other words, the rock cycle is a continuous process through which rock are formed, change, and recycle over time. The key processes involved in rock cycle include magmatisms and crystallization, which is the basis to form igneous rock. Then we have another process known as weathering and erosion. The process leads to formation of sedimentary rock. Then we have lithification, that is cementation, which led to the formation of sedimentary rocks. Then we have metamorphism, that is the formation that is caused by heat and pressure, which leads to the formation of metamorphic rock. Then we have melting process that leads to formation of magma rock. No rock is permanent. All are part of endless cycle. Now let us look at minerals. That is definition and classification of mineral. By a word of definition, minerals are naturally occurring inorganic solids with a definite chemical composition and crystalline structures. Now we have some classification of mineral. That is the primary classification by chemistry. That is according to their chemical composition. We have silicate. These are mineral that is made up of silicon. That is 90% of crust. Example, the quartz, feldspar. Then we have carbonate mineral that is made up of carbon. Like example is calcite, dolomite. Then we have another classification which is oxide, which is made up of oxygen. Example is hematite mineral. We have sulfites. Example is pyrite. Then we have number fifth mineral, that is native element, that is made up of gold and diamond. Then the identification is by hardness using Mohs scale, streak, luster, and cleavage. That is how we can identify minerals and its typologies. Now let us look at soil formation. Soil, by word of definition, is dynamic, life-supporting layer of minerals and organic matter. Soil is made up of soil formation is the composition of five major factors. Number one factor is climate. So climate is the major factor that leads to soil formation, mostly influential, like temperature and precipitation. Number two factor in soil formation is living organism, that is human beings and animals and the plants that helps in soil formation, which add organic matter to the soil. Number three factor is organic material, like in form of humus. Then number four factor is reliefs, that is topography, which affect drainage and erosion. Then number five is parent material, like source rock and materials. Then the number 6 factor is time, which is the passage of time, that is century to millennium. So these are the factors that contribute to soil formation. Having known that, let us look at soil profile and their major types. Soil profile, according to horizon, we have O horizon. The O horizon is made up of organic litters. Then we have A horizon, that is the top soil, the top layer soil, which is rich in humus and organisms. So there is so much humus in the A horizon, which is the top soil. Then we have B horizon, that is the subsoil after the topsoil, which is the accumulation of leach materials like clay. Then we have C horizon, which is weathered parent materials. Then we also have the arrow horizon, which is the bedrock. Now, the major global soil types, apart from sandy soil, loamy soil, and the clay soil, the major global soil type are: one, pedafer, which is forest soil of humid region. So pedafer is forest soil of humid region. We have pedocal, which is dry grassland or desert soil. Then we have laterite, which is intensely leached. It has nutrient poor tropical soil. So these are the major global soil types. Now let us look at natural resources from the rock. So natural resources may be extracted from rock. That is, the earth crust is our primary source of non-renewable resources. Number one is energy resources. Resources like fossil fuel, like coal, oil, gas from sedimentary rocks. So energy like fossil fuel such as coal are extracted from sedimentary rock. We have uranium, that is nuclear, from specific ore deposit. Now, number two resources is metallic resources, which is extracted from ores. Example, iron from hematite, aluminum from bauxite. Then we have non-metallic stroke industrial mineral, which is in form of limestone, that is cement, gypsum, the wallboard, and phosphate, like fertilizer. Then sand and gravel used for construction. So these are some of the resources from rock. We have also a gemstone extracted from diamond and rubies, etc. Now let us look at natural resources from soil. Soil is a vital finite resources providing critical ecosystem services. Natural resources from soil are classified according to their base. Like in agricultural base, it is the medium for 99% of global food production. So agriculture serves as 99% percentage for the provision of food globally. Now, raw material can also be extracted from soil. Raw material for like clay for bricks, uh, ceramics, and sustainable construction. So clay are extracted from the soil, which are used for bricks. Now, ecosystem services such as water filtration and storage, nutrient recycling, habitat for biodiversity, that is source of medicine like antibiotics, carbon sequestrations, that is climatic regulation. Sustainability challenge, soil deregulation threaten these services. In conclusion, that is the key takeaway. Earth dynamic interior, that is core and mantle, drives surface processes, that is plate tectonics and volcanisms. The rock cycle illustrates the continuous transformation of Earth's materials. Minerals are the fundamental building blocks. Soil is the life-sustaining product of their breakdown. Rock and soil provide the essential natural resources that underpin civilization. Final message: understanding Earth structure is not abstract. It is essential for responsible stewardship, enabling us to manage resources wisely, mitigate hazard, and ensure the long-term health of our planet. Thank you.